guys. It really is. Okay, so I'm like almost in tears. I'm so happy that something's working. Okay. So we're gonna look at the 514 notes today, which is again just more of the same of what we've been doing. It's just, are you using sine, are you using cosine, are you using tangent, to try and work through the different angle properties. So I don't know where we stopped on Friday. Nope, on Monday. One of these days I'll know what day I'm talking about. So these are actually the 5.23 or 5-23. That's the top or the last of the notes from 513. But we're going to go ahead and do it because it is just some more quick examples of sine, cosine, and tangent. So looking through, thinking about our sine, cosine, tangent, or our SOHCAHTOA, SOHCAHTOA, sine, cosine, tangent. Oh, look at that. That is almost the same as the problem that we just did on the blue sheet. So our angle, our theta is again the big important part. So from theta, that's how we decide what everything's labeled. So we have, when you look at this picture, theta, you have a 12 and a 24. Theta's kind of stuck in between. So that's how we're able to tell. Oops, let me undo. I'm going to grab that one. Here we go. So I'm kind of highlighting here the two sides. So our 12 is right next to our angle. Our 24 is also next to it, but 24 is the bigger side, so that's our hypotenuse. And the 12 is next to it, that's our adjacent. There's no opposite in this picture. So in this problem, we have A with H, which means that we're dealing with a cosine. So that's another reason why I always label that SOHCAHTOA, so I can look and kind of go, okay, AH, which one is it? Okay, AH has the C by it, so that's a cosine problem. We are looking for the angle. So if we're looking for the angle, we're going to use our inverse. So this is just kind of what we were talking about on the blue sheet. Now I'm going to type that into my calculator. And I have a lot of tabs open. There we go. So if I type this into my calculator, I'm going to do my cosine. So I'm going to hit function, cosine inverse, and then I'll do my 12 divided by 24. And this time I get 60 degrees. On the blue sheet, we had sine inverse of 12 over 24, and I got 30 degrees. So depending on the angle, it does matter. But there's my answer. So I just get 60 degrees and I'm done. I like doing the angles. Those ones are a lot faster than any of the others. For part B, theta, I've got an opposite. I have no hypotenuse. I've got an adjacent. So that's a OA are the two parts I have. That means that this is a tangent problem. And some of you might have already recognized that, hey, wait a second, OA, or I have an 8 and an 8, they're the same. If the sides are the same, then the angles have to be 45 degrees. If you're not sure, you can do your inverse, 8 over 8, that one. So I could do my function, tangent inverse, 8 divided by 8, and sure enough, I get this nice whole number. Again, they're not always going to be whole numbers. It's just this is some of the particular cases that it happens. Okay, but here, even though it doesn't look like it, and that's what they mean by not drawn to scale, the sides are equal, which means the angle has to be 45. For the last one here, I have a 57-degree angle. I can see from that angle, I've got an opposite, and x would be our hypotenuse. This time we are not going to use the inverse because we already know the angle. So this is a cross multiply problem. So we have to be careful about what we're given because that changes how we do it. So if I'm going to have to cross multiply, I have an O and an H. So that's going to tell me I'm doing the So look, I've used one of each. I'm going to use my sine problem for this. So I'm going to say, let's see here, OH That makes this sine. This time, instead of theta, though, or instead of my inverse, I know the angle is 57. And so I'm going to set it up opposite over hypotenuse. The hypotenuse is the bigger number. That goes on the bottom. It's just an x this time. So we can either figure out our decimal for sine 57 and then cross multiply, or we could cross multiply the way it is and just type it into our calculator and let it do the decimal. Either way is fine. I know that, let's see here, I'm going to write this over here. I'm going to write it with the x times sine 57 equals 7. 7 got kind of funny looking there. So I want to get x by itself, so I'm going to divide by that sine 57 on both sides. And I ran out of room. That goes away. Okay. So I'm going to type into my calculator 7 divided by, I'm going to write this cleaner, 7 divided by sine 57. You can use the decimal, absolutely. It does not matter. It's still going to get you the right answer. So 7 divided by sine, oops, that's cosine. Let's try that again. 7 divided by sine 57. I get 8.35. It'd round up to 35. If I had just done, enter, sine 57, and then done 7 divided by, what do I have? 0.8387. I basically get the same thing. The more decimals you use, the better. If I had just done, let's see here, 8.3 instead of 8.38, I don't get the same. So the more decimals you use, the closer and closer you're going to be to the right answer. So that's one of the big things I know people have done or had issues with in the Delta Math program is they're not using enough decimals. So if you just use the exact value, the sine 57, you know you're going to get the answer right. I said 835, right? 8.35. There we go. There's our answer. Okay, so the rest of what we're going to look at today is just more examples of the same thing. So if I was looking at, it says trig ratios coupled with a Pythagorean theorem give you powerful abilities to solve problems involving right triangles. So Pythagorean theorem, a squared plus b squared equals c squared. So climbing in Yosemite, David and Emily are climbing El Capitan, a big wall cliff in Yosemite National Park. David is on the ground. So here we can see, here's David on the ground holding the rope attached to Emily as she climbs. So here's Emily up here climbing the cliff. And we can kind of see just forming that rope forming a triangle. So we're going to use that to kind of help us figure out our problem here. The rope is attached to his waist about 3 feet off the ground. Hey, we've done these before. So normally it's to the eye level that we've made our triangles. Now we're just going from the waist down. So about 3 feet off the ground. And he has let out 40 feet of rope. So the rope is 40 feet long. So that's actually this number. The rope makes a 35-degree angle with the cliff wall. So I put that in bold because the angle is not with David. The angle is up by Emily on the cliff. So, and that's a 35-degree angle. So it says, assuming the rope is pulled taut, or meaning tight, how high up the wall will Emily have climbed? And we're going to remember to add an additional 3 feet to whatever we get, because the 3 feet is outside of the triangle. So we just want to know, how high has she gone? So we have a situation that kind of looks like this, where we've got our angle. We're assuming that the cliff, because it's a sheer cliff, is straight up and down. It's going to make a right angle with the ground. So now we have this right triangle. So we have, from our 35-degree angle, we're looking for the x that is next to the angle. So that's our adjacent side. And the rope, which is pulled across out in the air, that would be our hypotenuse. So if we're using a with h, now it's just a matter of, am I using sine, cosine, or tangent? Anybody know? Now that we're getting better at these, I'm just checking the attendance really quick while I have a downtime. Kaylee was gone. Lily, Ada, Logan, Bailey, Ashley, Josh, Braxton, Harley, Hope, and Owen. Okay. So if I'm using A with H, that's going to be cosine. Okay? The more you do it, the easier it gets. So if I'm using cosine, I know the angle, so the angle goes next to cosine. So cosine of 35 equals our adjacent has to go on top, and the hypotenuse has to go on the bottom. So A would be our side that we're looking for, and our hypotenuse would be our 40. So now we can just crisscross applesauce, cross multiply. I'm going to do 40 times the cosine of 35, because when I multiply this, or when I make my x, I can see that these two are going to multiply together. So I'm just going to type that in my calculator. Clear, clear. 40 times the cosine of 35. And I get about 32.7677. Remember that we do have to add our 3 feet from David's waist down. So she's really about 35, almost 36 feet up in the air. The other question then, or the next question, is how far from the wall is David standing? So we want to know the distance on the bottom. So we could make that another variable and do another trig function, or we could do our Pythagorean theorem. You can use any method really at this point. You could use sine, you could use tangent. We could actually figure out the angle by David and then use cosine again. There's a ton of methods that we could use at this point. It's really a matter of which one you guys feel is the easiest or the best. I'm going to just go ahead and use, so now I'd be, if my angle's 35, this would be my opposite side, and I still know my hypotenuse is 40. So if I use O with H, I think it's fastest to use sine cosine than it is to do Pythagorean theorem, because it's just a quick cross multiply as opposed to a squared plus b squared equals c squared. So I'm going to use sine, I'm looking at my time here, trying to make sure, of 35 equals, this time my opposite, I'm going to call it y just because, over 40. And it's another just quick cross multiply. I don't have to do any extra addition. Of the 3 feet, because I'm not talking about the height anymore, I'm talking about the width. So I just need to type in 40 times the sine of 45. 35, I wrote the wrong number in there. Try that again. 35. There we go. Try that one more time. 40. So actually I could go in here and I could just, wonder if it'll let me pop that out. Aha, it'll let me. I don't know where that 4 came from. 40 times the sine of 35. There we go. 22.94. So he's basically 23 feet away, holding the rope while she's climbing up. That's really all that's what it's talking about there. And that seems like a pretty, that way, not to get morbid or anything there, but if she falls, she's not going to fall right on top of him, right? That would be really bad. So he's got to, give her some clearance in case, just in case. Okay, let's try one more here. Yes, there are these other ones down at the bottom, but it's just more of the same. Now we got someone who's watching her climb, and that's kind of weird. This is just, again, some more of the same types of problems. The Bungling Brothers Circus is in town, and you are part of the crew that is setting up the enormous tent. The center pole that holds the tent up, so this pole right here, is 70 feet tall. So that's a 70 feet right in the middle. And to keep it upright, a support cable needs to be attached to the top of the pole so that the cable, and here's the trick, forms a 60-degree angle with the ground. So the angle is actually 60 degrees at the bottom. So our first question, how long is the cable? That's the hypotenuse. So I have from our angle, our opposite, and we're looking for the cable, which is our hypotenuse. So here again, it's just another sine problem. So I'm going to do sine of my angle equals my opposite, and now I'm looking for the hypotenuse. This time, if I try to cross multiply, x doesn't go with the 70. I'm sorry, the sine doesn't go with this with the number. I have x times the sine of 60 equals 70. So I'm going to have to divide by the sine of 60, which is going to give me something. So I have to do 70 divided by the sine of 60. And I get about an 80.8, 80.83 foot rope. So, which makes sense because if the tent stake is 70 feet tall, the hypotenuse has to be bigger than that in order to reach the ground. We can't have a rope that's less than 70 because then it's not going to touch, right? And then the last question here, how far should the rope be away from the tent? So it's just another one of those, could we figure out the bottom number? You could do your opposite over your adjacent. You could do your adjacent and your hypotenuse. You could do Pythagorean theorem. It's really just a matter of which one you're going to do. I'm going to do opposite and adjacent because, again, I think it's faster. So that's a tangent problem. And if my opposite is 70, my adjacent, I'm going to call it y. And now it's exactly the same thing. It's a cross multiply. And because of how I multiply this, y is going to multiply with the tangent of 60. Something that I do notice, or I don't know if you guys have noticed this pattern at all. Every time the variable is on the bottom, you're going to end up dividing by your sine, cosine, or tangent. So if the variable is on the bottom when you set up your fractions, you're going to have to divide to get your answer. If the variable is on the top, you would just multiply. So I get the rope needs to be staked down about 40.41 feet away. Boom. I'll move this over that side. There we go. I know we have only about 2 minutes left here, so I'm not going to worry too much about these other ones. They're just more of the same. Where's my mouse? It's on one screen, but I can't get it to go onto the other one. It's not showing up. Oh, there it is. Okay. These are just, it's one more example of the rope climbing problem. This one is trying to get you guys to do a little more with the angles, but it's still just a bunch of Pythagorean theorem. So, or I mean sine, cosine, tangent. Say the right thing here, Julie. So here, Nathan is now watching Emily climb the rock, climb the mountain. And his angle is 10 degrees. He wants to know how high up she is. His eyes are 6 feet above the ground. So we do the exact same thing we did on the first problem, opposite adjacent, and then add the 10. So really this is, I'm sorry, add the 6 feet. The angle is 10 degrees, opposite over adjacent. It's a tangent problem because it's opposite and adjacent. And then you're just cross multiplying real fast, add the 6 feet because his eyes are 6 feet above the ground. So the more you do them, like I keep saying over and over, the easier they do get. Oops, that didn't do anything. How about my answer? Plus 6. There we go. So she's about 38 feet up at that time when he's watching her. So I'm going to write plus 6. I forgot my number. 38.62. And that's all it is. So nothing too crazy. Part B is just more of the same. Now the angle's 25 degrees instead of 10 degrees. So it's the exact same problem, just with a 25, tangent of 25 instead of tangent of 10. So it's 9:04. I don't want to keep you guys because I know I did that on Monday on accident. So I'm not going to be too worried here about getting those last couple of problems done. That was it. Those B and C are all we missed, but I think we did a much better job. I think I'm a little more calm today. I'm not freaking out. So we do have a quick little quiz tomorrow over just, can you do sine, cosine? Like half of the quiz is just, can you tell me what over what? You don't even have to put anything in the calculator. It's just, if I did sine, what number would go on top and what number would go on the bottom? So it's going to be a real quick one. And then you like your chance to reset and all of that. So we'll do that real quick tomorrow and we'll talk about some 45 triangles. Yay! All right. Have a good rest of your day, and we'll see you later.